I'll now call Simon Kim. Simon Kim is an architect and designer and in the partnership firm of Ibanez Kim. He's worked with Zaha Hadid Architects, Gehry, and SOM. Simon Kim's work is defined as a genre-defined practice that explores emotive and sensate aspects of imagining spaces. Simon?
So the last time that the five of us together were together, Sujit, myself, Mark, Jason, and Alvin was 13 years ago, right? So I'm really pleased to be here with them, also with you and the students that came to our presentation. The work that I want to show you today is going to be an exploratory answer to a certain brief that Sujit laid out in terms of design, what Alvin pointed out as the kind of a hierarchical nature of the digital, which should be subsumed within the architecture itself. No, we don't, or certainly I hope not to give it the most importance, so where it has a level of privilege. I would rather see it that it's something that is the basis for any number of explorations. As Deepti introduced me, I am a partner of an office. The other person is Mariana Ibanez, who is a professor at the Harvard GSD. So I hope to show you a range of projects that talk at a certain scale, that goes from the small to the very large, and also works to present architecture that is more than just inert, stable geometries, but that can be alive, can express agency of its own. So this first project is something that we did when I started teaching at the University of Pennsylvania. There is any number of open spaces that are derelict. It's not because it's waiting to be developed, it's just there's nothing going on, and because of the sizes of the spaces, it's hard to develop them. So we always saw that as a design opportunity. Can you hear me well, or? All right. So these empty spaces became pockets for us to fill with these characters, these strange little architectural people. And as they moved around, the mental mapping of Philadelphia could be changed. So you can see that any city could be remapped, it could be re-understood or interpreted in a kind of network scenario. So you can see some of the pavilions in this kind of stage, this urban stage, and as you walk around the city and you see these characters, they have a kind of connection to each other, they speak to each other, and they can also project a kind of a difference in mapping. We have them with names. The Fat Controller, the Empress Dowager, Romulus and Remus. And I don't know if this is going to play as a video. Yes. So as you can see, we can activate any number of these nodes. And again, of course, we're not pretending that Philadelphia is a sort of liquid city that we can distort, but in a certain way that the mental projection of the city, in the way that we understand it, can be distorted. So here you see that we can move things around, we can access different zones of Philadelphia and also different land values and prices, and perhaps collapse them so that what is expensive here and what is derelict over here can actually be contiguous. So this is the kind of underlying geometry of it. And to show you that these characters can have different traits. I'll just keep going. So you can see the traits as I show you. There's a kind of higher order and a lower order, so that each character can have locality and they can have context. So the one on the lower left, right, is giving out free Wi-Fi. Right? It's just pouring out Wi-Fi, making connectivity not an issue. The one next to it, enormous inverted cones of ice. And as they are positioned on this table, they can then be responsive. So as you move these around, you can actually, I have no idea if this is going to, nope. As they move around, you can actually have them, with fiducial markers, track where they are, and also know where you are in that city. This goes to the lab work. So we are two groups. One is Ibanez Kim, the other one is immersive kinematics. And in this group, we let fly with potentials and availabilities of new media. And when I say this, I'm going to try to make it very clear. We have always been working in media. Architects communicate and we traffic images to be built by someone else, somewhere else. We work with pens. When I was in school, it was Mylar, and I was drawing on it with Conte or with rapidograph pens. We have now new media, and it should not be seen as a kind of break in tradition, but simply more ways that we can fulfill these design interests that we have. So in this case, this is an architectural solid, right? It's a primitive that all of us are familiar with, but that we can then expose, that it can break apart and create an entirely new object. And this was done in this manner. It was a competition for a kind of a jewel box that can be opened up in the center of Philadelphia. And that led directly to a competition for the PS1 in MoMA. Every year they invite 5 offices to pitch something that's going to be built in their PS1 courtyard. Mariana and I thought that this was a good chance to re-explore this sort of a hinge dissection, so that we made this full-scale prototype, and you can see that it can break open, it can be any number of different scenarios, so that our idea was that when you go to the PS1, it's never the same environment twice. You can change it and move it as needed. And the reason for this was that the courtyard for the PS1, we considered it to be a kind of extension of an urban stage, right, where a life is always kind of seen as a kind of theater where you are on the outskirts looking in, and we thought that it was an interesting way to produce this en masse, so that it's not just humans who are on stage, but it's also the architecture that can be equal participants. So this is a physical model of it in one stage, right? So each one of them also had names. I won't go into why we give them the certain names that they do. I love me some names. So the order of this was the kind of, again, this combinatorics, so that each one of these sort of ciphers, they have needs and desires, so that, you know, Agent X loves Agent Y, but does not want to be near Agent Z. So there's a kind of negotiation of how they travel. This was expressed in different ways. We also wanted to show that these pieces could be from the level of furniture in the courtyard to what can be canopies, what could be rooms. And you can see here in the full-scale prototype the different ways simply that you can combine, right? So it's the one object, it was, and then it can flip open or close, and it can have different positions. This was a diagram to just show how easily it could be assembled without any kind of real skilled labor. So any number of students can come together, a whole team of students, which I just finished one of them today, and you crank out different possibilities. We also had this idea that with the phone, you can scan these objects and bid on them. So it's not just a kind of you create something out of cheap material, which is scaffolding, and then it goes back into the waste stream. You could also imbue it with value. So you can bid to purchase these items. So here it is in the courtyard in kind of a situation of these living rooms. Here it is in one of these colonnade scenarios. And in full party mode, so that as the music's playing, these things are moving back and forth. They can track across the sky in the sun, or at night it can just be this pulsing light box. All super not dangerous, let me just show you. We work in other ways as well, and when I show these, I always want to talk about it as architecture. We work with dance. So in this case, we made these non-human dancers. So here you see humans performing with them, and this is a workshop that we just tested this scenario to make sure that we knew what we were doing. So as the humans move, we have the non-humans moving with them to suggest that performance isn't just based in one animal, but it could be in the non-human as well. So here in this, you see the kind of the robot arms we have, and also this sort of dancing geometry on screen to suggest that when the humans are moving, we have these accelerometers on them, just like you have in your phone. So as they are moving, as they are kind of tracking across the stage, their movements are being transferred and translated into geometry that is moving at the same speed, in the same hopefully languid or explosive movement to suggest again that performance is shared between different agents. So here's a close-up of one of these objects to show you how we were producing them. And it is part of a larger discussion. We have a modular roboticist that's part of our lab. His name is Mark Yim. And his métier is to deal with blocks of things that join with other blocks of things that produce differences as needed. So unlike humanoid robots that you see in your space age movies, these are not fixed, but they could be bipedal, they could be locomotive as snakes, and they can roll. Right, so in this method, you see one of our little robots, as it rolls along, it hits a certain obstacle, it unfolds, and then, like a snake, goes underneath that. Here is a biped.
Modular robots are capable of a variety of configurations and modes of locomotion, including bipeds that can stand up
really
and walk.
Intelligent, but I want to talk about it as architecture.
Modular robots can also be robust in a variety of situations, as we will establish in this video.
So basically what you're
This system, called CK-Bot, is made of 15 modules arranged in 3 clusters of 5. Each cluster has a camera module with a 20 frame per second video and LED blinkers as well as accelerometers.
My interest in this,
the other 12 modules each have an embedded computer, position and proximity sensors, and a 1 degree freedom servo that has a rotational range of 180 degrees.
But that it can be scaled up. So the cost of robotics isn't that we lose our souls or that we lose our agency as architects, but they can present new types, they can present new communities as needed. So here you can see that the one that we produced as a wavegate, why could it not become a moving house, right? So that is simply given over to new terrain. It can crawl through forests, or it can be an emergency vehicle in earthquakes or in war-torn areas. I try not to be an activist architect, but that they can be different as needed. So here you see it in Siena, and The reason why we get into this kind of thing, again, to assure you, is that architects have been working in media that is non-successful drawing, building, but it could be that you are building prototypes and creating space that is, again, disruptive to expectations, but not breaks in tradition. So here we have the work of architects. This is Walter Pichler and Hans Hollein from the 1960s, as well as the group Archigram and the very young Wolfpricks and Coop Himmelblau, to suggest that architecture can be as small as a room on your head, that it can be wearable, that architecture could be inflatable, which in the 60s was a remarkable new medium to have plastics. The architecture can be shared, it could be singular, or it can be a device just sitting in front of your face. So the work that Mariana and I have been producing has been very much in a range of sort of exploratory. Not architecture that's reduced downwards to the smallest and then blown outwards, but that they can be in any kind of material and at any scale. So this is our first investigations into curvature of sheet material. In this case, it's wood. And we built it up to a small pavilion, this monocoque system. It's plywood that is forced into double curvature by bending it and locking it into place. And because you do so, it creates a very strong skin. And aggregated with others has a kind of, it can become a very strong shelter. That's not my son, by the way. Right, so we start off small, we make these little models, we go from paper, we go into the almost like these 1 to 20 scale. And we do this in two ways, digitally and in physical material, because what you learn from making with your hand is as important as what you do with defining parameters on your screen. And so here you can see Mariano with a full-scale panel. So here's a detail of it. Here's the first representation. And that immediately translated into the second thing, which I call the elephant, lovingly. Working at Frank Gehry's office, working at any office, you will learn several things. And at Frank's, it was how to take ruled surfaces and learn how to clad that. So what Alvin was saying certainly applies. The frame and the skin are not exactly the same. So what we have to do and what we learned and applied here is what Gehry calls the quake line. So if you have this ribboning surface, what you need to do is to find the line along which there's minimal bending. Right? So therefore, your panels can be guaranteed to lie flat. So here we have thin wood veneer. Tough wood may very well be the next vendor for this. And it's stretched across the frame, and this is basically a project where it is a room inside a wall. And it was presented in the, this is in the Boston Society of Architects Gallery in Boston. And this is the diagramming for it. Right? So on the left, sorry, on your right rather, you can see how there's a wall that gets separated, inflated so there's a space within, and that how that then gets produced, always the same for us with physical testing to make sure that this quake line idea that we have actually holds water. And this is the sort of outcome. This is my son. So you can see the kind of room that's exposed when you have these two lines, you spread them out, you allow them to sinusoidally move, and then have interpenetration to create this room. In this room is what I'm calling our fathers. So there's a gesture-based system and interaction. You bow or crouch to enter the room, and as you come up, a motion sensor knows that a human has arrived and turns on a blinding light, just like these ones, just to shock you out of your senses. And then as you gesture around blindly trying to find out what's happening, it triggers the sound of dead modernist architects, and they're all men. So Walter Gropius speaks out about his position on architecture. Mies van der Rohe pontificates boldly about what he believes architecture is. Kenzo Tange, Charles Correa, and they're all dead. So this is basically an indoctrination chamber for all young architects. And so it's, for me, quite a beautiful volume because there is never one way that you can understand it totally. And it never gives away the fact that it is this thick, stretched very, very tightly along a small frame. And here you can see it from the outside. That takes us to the next interactive object. This is called the confessional. So it was made for the Lawn on D. It's at the Boston Convention Center. We all hold secrets. Some of them are more deeper than others or darker than other secrets. And what happens when you're confronted with a cone as a human? I'm not sure if that happens in Asia as much as it does in North America, but generally people want to look into the face of a cone. So we take that on as a kind of behavioral set, and we made cones out of an octahedron, a truncated octahedron. And so as you look in, there is a motion sensor, there's a microphone, and a light. What happens is that it will record what you say without any kind of judgment. It holds that recording and then releases it at a later time with your voice given an octave lower. So it hides who said what secret. No, if you say, I hate architecture, but I'm stuck doing it now. I've been in it for 20 years. And so this is again, the physical model, because if you're working with cones, you're not sure how you're gonna work it, how it meets at edges. So there is the digital file in which you can produce any number of wonderful things without gravity. And then you have to produce these prototypes to ensure that there is an understanding of it. Funny enough, when you will work with new media, and all architects will, how you design interaction is another dimension of our work that I'm sure is going to become broader in schools. What that requires is a sense of duration. How long, for what magnitude, in what degree, so that it's not just you moving in space, right? These are what Corbusier calls the magnificent volumes illuminated in light, but also how those magnificent volumes start to move and to speak back to you. And in what ways it's friendly and what ways it is threatening is a degree in time. So here you can see it when it's in full expression mode. Here it is, it's screaming out the secrets it's collected over the day. And it turns purple with rage as it's doing so. Here is a vault, a thin shell that was produced. It's an intersection of different barrels. And here it is in all of its variations. And I was telling the students earlier today, it's not simply the fact that the computer can produce many of these things for you. And when it's tethered to a 3D printer, there is no loss of variation that can be produced. What is important is to find or give yourself the authority to produce value judgments. This is important more than this one. And for what reasons? Going back to the urban scale, we now went to Washington, D.C. to look at how we can try that urban experiment that we did with the Philadelphia mask. So this is a very interesting, for the US, urban morphology. It is the work of a French architect, L'Enfant, and how he produced these avenues of power. Right, so there is the, this kind of Masonic symbol stretched over a grid of city streets. And at each intersection is the White House, is the Senate, is the Washington Memorial, connected in lines of sight with each other. And so we were interested in how these lines of sight have not produced better democracy. In fact, humans are fairly squeezed out. It is simply an expression of dominance of government over citizens. And we thought it's a better way of looking at democracy where we can say that we can create new land values and create new urban scenarios. So these are our agents, and they're working as a multi-agent system. They have rules of engagement, just like as before. And as a computer code, we're not computer scientists. One of my previous commenters was saying that they're not trying to be engineers. Certainly we're not either. So we communicate to each other through graphics, and this is our way of showing computer programming. So that when things are moving, you can suddenly have now new displacements of Washington, D.C. to create huge swaths of collective spaces for public parks, for spaces of gathering and discussion. So this will demonstrate a certain. I just did something to the computer. Can I get some help? Sorry.
It's playing.
It's playing?
근데 제가 지금 거기로 가려고 하는데 어떻게 가시는지 혹시 아세요?
So as you're moving the agents around, you can see that the landform of Washington, D.C. Responds immediately. Again, Washington, D.C. really isn't going to do that. It's just more of an urban exploration. But you can see that as these things track, there is a physical system that has control over a digital alternate reality. This is my wife's thesis at the AA. I'm just going to talk about it really quickly since I am not the author on this, but that there is a kind of a reciprocity where there's pulses of traffic and people. Alvin probably knows more about this than I do. The reason why she put this in is because it is where we first began our investigations into what, again, is this non-human agency, so that there is building systems that have their own desires and their own mobility so that they are working autonomously for or not for us. Right? So what that group had done was to say that there was this kind of a mesh system that can be opening, it can be closing, you can curate the affects, you can curate the environment, and that it can also be autonomous and free-ranging on its own wills. And so you can see how it moves. And this is some of the student work that we've been producing for this. So you can see here how our students are working with interaction of its own, so they're producing its own new kind of disciplinary values from the sensate, where you can touch soft surfaces, or from the collection of sunlight, the dispersion of different sizes, so that you can have architectural systems always at full scale. So when I talk about these things as prototypes, I do not mean them as models. We're not working at 1 to 100 or 1 to 50. We're working at full size. So this is a building panel that could be new ground or a new wall. and that it can be lit up, it can be exploratory, it can be also soft, membrane-like, so that you feel comfort as you interact with it. This is another wearable device, just as Hans Hollein and Walter Pichler had produced as an idea. As you wear it, you can disappear into your own cloud of smoke, right? Or the cloud, as with its paradoilic readings. This brings us to the next project which we worked with. It was with an opera company. So the Philadelphia Opera is struggling to keep a certain relevancy with the youth. So they contacted us to try to create new ways of thinking about theater. So we, again, worked with space, human, and also the non-human. So Eurydice, in this case, is being killed by the serpent, and the serpent is a soft robot. So as she's singing, the coils of the snake wrap around her. And as she lies dead on the stage, much later in the performance, we have motion tracking, face tracking. And when there is the song, she sings to Orpheus, turn around and look at me. And Orpheus dares not, lest he breaks the rule and she returns to Hades. So it tracks the audience if they're turning to look at her as they move around the stage. So this is the testing of the soft robot. And this is just a short video. So this is one of our employees trying to look as solemn as she can as this thing squeezes around her. And then for this one, Tarek is demonstrating the idea of taming the Furies. So as they try to tear Orpheus apart, he tames them, and in this case, they're polyhedra, screaming at different levels. As he places them on top of each other, and they do face matching, their tones average out. And so in a way, what we are hoping to do in a much larger architectural sense is to have this sort of field of these robots, these field of soft kinetic elements, so as you pass through, it travels with you. So this is some of the pieces that we're trying. A student of mine at Yale produced this. And I don't know how am I doing for time? So this is one of the latest things that we've produced. It's with Andrew Witt. We were looking at, again, this small architecture, and we made carbon fiber monocoque. And in this case, this is called, this is another one of the confessional series. So on the stretched surface is flex sensors, so that as you push and pull, you can control sound and light. So this is a different kind of qualities you can get as you're wrapping the carbon fiber. So carbon fiber can come in sheets or it can come in spools. What our interest was to produce an idea of, can we make on one flat surface enough thickness that it starts to produce surface affects like moire patterns? And how much wrapping would that require? So again, from the digital, right, which for us is just simply a kind of an expression of desire, to then physical testing, always with the physical testing. So you have this object that can tumble around. So there is no one way to situate it or to inhabit it. So this is with a human inhabitant. And with the stretched surface over her. I think I'll stop with this project. This is something that's exploratory in terms of agency in architecture that doesn't really require mechatronics because a lot of what we've been showing you has been built upon needing tremendous amounts of current. Right? So there might be situations in the world where you don't have as much access to electricity. So how can things move and tumble, not because of giant motors, but because of its own self-motility through geometry? So here you have this sort of idea, this sort of community of homes, and so the rider moves away and the passenger has to rock. Right? So you can have these homes that are indeterminate and moving. To this idea that there could be springs in buildings so that you can actually have something that's shuffling along a landscape. To the very large now, where you can have something rocking on top of something else that's rocking. So we've produced some work in concrete, and this is, leads us to what we did today. So the students here helped me to produce concrete that is full of charm. I love concrete. I don't mind seeing it everywhere. I do think that it could be a little more expressive. So this was my first exercise in making it alive. So this is our first time where we put piezo contact mics. So as you rub or touch concrete, brush up against it, its internal matter will vibrate, and it will transmit that vibration to the piezo mic so that you can actually create beautiful soundscapes. Don't know if that's working. Oh, here it is. And in this one, Joseph is playing with a soft envelope. So if you take concrete and you wrap it in a neoprene, you can actually have the illusion of objects inside objects, so that there's a kind of skinning, there's an envelope, and then there's the actual reality of how much is inside within. I don't know if you can hear that at all. But okay, I think that's it. Yes, okay. So this is one vision of that in the city. Thanks very much for your time.